We're going to look at the difference between a perpendicular bisector and an altitude. Both an altitude or a perpendicular segment and a perpendicular bisector meet another line or segment at right angles. So they are similar, but they're also different in that one bisects and the other may not bisect. So here's the definition of a perpendicular bisector. A line that divides a line segment into two congruent parts and is perpendicular to the line segment. So notice the geometric notation. The geometric notation for perpendicular bisector has both the hash marks to indicate that the two segments, the segment that's been bisected, the two halves are congruent or they have equal measure, and that the line that is the perpendicular bisector is also perpendicular to the segment. An altitude, or the height of a triangle, is a perpendicular segment from the vertex to the base or to the line or plane containing the base. So notice here, AD is perpendicular to BC, but is not necessarily BC's bisector. Also, the altitude or the perpendicular segment can fall on the outside of the triangle in the case of an obtuse triangle, or it can fall on the triangle itself. It could be a side if it were a right triangle. Imagine a right triangle ADC, where AD, the altitude, is also the side of the triangle for ADC. So the next question is, how do we construct an altitude or perpendicular segment versus a perpendicular bisector? A perpendicular bisector is fairly straightforward. We start by putting the point of our compass on one of the endpoints of the line segment we are trying to bisect. You'll notice that it's going to be different for the height or the altitude, where we're going to put our point of our compass on the point that we want to be on a segment that is perpendicular. So notice the starting points are different. Perpendicular bisector, start with a point on the segment that's to be bisected. Now, there's also means of determining the midpoint. The midpoint is going to be on the perpendicular bisector. So this is also a means to find a midpoint. So using your compass, adjust it so you have a particular radius. The radius itself is going to be a little bit larger than 1/2 that segment to be bisected. Make arcs on both sides of the segments, approximately half the distance horizontally. Let's just check to make sure that's done correctly. Sometimes it changes. So this is the case. Go ahead and readjust. Sometimes the point can move around. Throw an arc on one side, throw an arc on the other, and then go back and just make sure that it's the same, hasn't moved. Move the point to the other endpoint, the point of the compass to the other endpoint, and throw 2 more arcs on opposite sides of the segment. And you're probably noticing, hopefully, that the distance from B to the intersections and A to the intersections are the same distance. So if we connect all 4, we have a rhombus. If we connect the intersections, edge, we have a perpendicular bisector. Now I want you to notice what I did there when I was putting the straight edge up against this pen. Strategy for making sure that you hit those intersections is to put the pen on the intersection first, and then push the straight edge up against that. You have to do some alignment for the second one, but it's a lot easier than trying to eyeball the edge and then put your pen down. Because that's a perpendicular bisector, I need to indicate as such with a geometric notation, perpendicular and congruent segments. There's a perpendicular bisector. Now, a perpendicular or an altitude for a triangle is the more difficult of the two constructions. Imagine that I wanted to build a triangle with vertices at P, A, and B. It would be obtuse. And so the altitude for this triangle with base AB would be outside the triangle. I'm not going to draw on those sides. I simply want to construct a segment that is perpendicular to line AB and it goes through P. So before I get started, I need to extend the line out enough so that I can get points that are equidistant from P. Now that I've extended my line AB, I can take my compass and remember that for perpendicular bisector, the point of the compass was on the endpoints of the segment. In the case of an altitude or a perpendicular segment, I'm going to put the point of my compass on the point that's going to be on a perpendicular segment. And from there, it really doesn't matter what the radius of the compass is, it just has to be consistent when I make both arcs. I'll make one arc on a line here and make another arc on the other end of the line. Notice that both arcs are equidistant from point P. I'll go back again and just make sure that it hasn't moved. It will tend to do so there. Okay, these 2 points, the intersections of the arcs and the line, and P, those are equidistant. Now I need another reference point on the other side of this line so that I can find P and another point, those 2 points defining a line or segment that's going to be perpendicular to this line AB. Using these same intersections and a radius that's the same or different, really doesn't matter, I'll throw 2 arcs that are equidistant from those 2 arcs and the intersection with the line AB. Again, making sure I check to make sure compass is not moved. And there I have my 2 points that will define the perpendicular line segment. And I'm not going to draw an entire line through here. I just want the height or the altitude or the perpendicular segment from P to the line. This will distinguish it from a perpendicular bisector. If I continued it, it would pass through that intersection. And then, because it's perpendicular, I need to denote that with the geometric notation. So I've constructed a perpendicular segment perpendicular to line AB. In most cases, you will have to extend the line. Sometimes you will not. In the case of altitudes for triangles, if it's an obtuse triangle, you'll want to extend the line as well.